Hello everyone. Today we will start reviewing the last unit of the book, Unit 11. 11.1, How we use energy. Firstly, energy. Energy is important for our life. But why energy is important for our life? The answer is, for example, if you need to do any kind of activities, any kind of exercises, these activities or exercises will need energy. We will take an example of this kind of activities. Let's say breathing. Okay, if you want to breathe, this movement of your body muscles, this it's a kind of activity, so it needs energy. Now, this is only one example of activities. We have also another activities, for example, when you are running, another example, let's say your heart, when your heart is beating, okay? So all of these activities, it needs energy. Now, from where do we get energy? Or how we can provide energy for these activities? As you know, the main source of energy for our body, it's what? It's the food. Okay, our bodies use the energy that we get from the food. Questions. You learned about food and digestion in stage 8 unit 2. What two types of nutrients are our main sources of energy? Last year we talked about nutrients. We said all when we eat food, this food, it consists of food categories, okay, or it contains nutrients. These nutrients are the protein, fat, carbohydrates, and the rest of nutrients. Now, which two of these nutrients are the main source of energy for our body? The answer, it's what? It's carbohydrates and fats. Carbohydrates and fats are the two main energy source for our body. What is the original source of energy we get from our food? Firstly, in question number 1, we said we can get energy from fat and carbohydrates. Both of them are source of energy. But which one is the original source of energy, or which one is the main source of energy for our body? The answer is carbohydrates. Then, more and more energy. What do you mean by more and more energy? It means, for example, let's take an example of our community. Okay, our community, as much as our community or our population, an example, if our population will increase, will be bigger, that's mean will need or will use more energy. This is what you mean by more and more energy. Imagine these cars, okay, as much as the population will be bigger, that's mean members of this population will be more, so these members of course will need for example more cars for transportation, for transporting. So when the number of cars will increase, so in this case we will need what? We will need more energy. Now, what we use energy for? Just you can ask this question for yourself and also give answer depending on your daily life. Okay, just ask yourself, how do I use energy in my life? You will see, for example, all the energy as it's shown in this pie chart. Okay, this pie chart, it shows that there are three main sectors where energy is used. Okay, industry, transport, homes, and offices. Okay, so all the energy that we use it in our daily life, we are using it in these three main categories: industry, transport, homes and offices. And also you can see, it's like if you have a question here, look at the pie chart. Which sector uses the most energy? Of course, here it's for the industry. Energy and development. Look at this graph. Okay, this graph it shows different countries and how much energy they use or they consume. Okay, for example, let's take this example, Africa with the USA. Okay, before looking at this graph, if you'll ask someone, you will ask him, what do you think, which country it's more developed, Africa or USA? Okay, of course, you will say, for example, America or USA. Okay, so when you will say USA is more developed, so what's that mean? It means, or why you will say they are more developed? Because they have more factories, so of course they will need more energy. This chart, it shows that the amount of energy consumed depending on the development of the country. 11.2, fossil fuels. Firstly, if we want to give a definition for the word fossil, we will say it's what? It's the remains of dead bodies. The remains of dead bodies or dead organisms. Now, fossil fuel, what's that mean? It means the kind of fuel that we can get it from dead organisms. What do you mean by dead organisms here? It could be animals, it could be plants. Now, energy resource. What do you mean by energy resource? It's anything from which we can obtain or we can get energy. As you know, if you will look at this pie chart, it shows the examples or the types of fuel resources in our daily life. We can get energy from oil, coal, gas, nuclear, and renewables. Now, you can see that the most of energy we use, it comes from where? If you look at these three, oil, gas, coal, these three, they form what? They form the fossil fuel. So the most of energy that we use in our daily life, it comes from fossil fuels. Now, which fossil fuel is used the most as an energy resource? Now let's take the example, let's take these examples of fossil fuels. Okay, which one of these three we use the most in our daily life? Okay, so the answer, it will be oil. Chemical stores. What do you mean by chemical stores? The stored chemical energy. Okay, where we can find a stored chemical energy? The answer will be in what? In fossil fuel. Okay, fossil fuels are stores of chemical energy. If you will take any example of fossil fuel, you will see it has a chemical energy stored in it. Where the energy came from. Now, when we talked about the fossil fuels, okay, these fossil fuels, it came from where? Okay, firstly, the main source, you should know that the main source of energy in Earth or to the Earth, it's what? It's the sun, sunlight. Sunlight is the main source of energy in Earth. The rest of energy resources, it comes by the help of sunlight. For example, uh, fossil fuel, or example, coal. What's coal? From where it comes or how it formed? So coal formed from the remains of plants that died millions of years ago. Okay, oil and gas formed from the remains of sea creatures. Now, the main source of energy for Earth, which is fossil fuel, example of fossil fuel, coal, oil, and gas. These three, they came from where? They came from, as we said, from plants, dead plants, or remains of sea creatures. But this plant, before it died, how it formed, what helped these plants to grow? The answer will be those living organisms gained their energy originally from sunlight. So now that's why we say sunlight, it's the main source of energy for Earth, okay? Because plants to grow, it needs what? It needs sunlight. Also, the sea creatures to grow also will need sunlight. Without sunlight, the life it's impossible on Earth. So the main source of energy for Earth is light. Now, why is it wrong to say that fossil fuels are stores of light energy? Okay, can we say fossil fuels, it has light stored energy? The answer, it's wrong. No, it's wrong. Why? Because fossil fuel, it has a stored chemical energy. Okay, the fossil fuel, it will form by the help of sunlight, but it doesn't have light stored energy in it. Okay? Generating electricity. The electricity that we have nowadays, to generate this electricity, you need another source of energy. So what we will have, we will have some, we call them stations, okay, power stations. These power stations, okay, to work, it needs also another source of energy. For example, a coal-fired power station in China. So coal will fire this power station in order to give a electricity. Okay, so most electricity is generated in power stations which can burn fossil fuel, especially coal and gas. So we can generate electricity by what? By burning the fossil fuel. 11.3, renewables and non-renewables. What's that mean? The source of energy that we have, we can divide it into two main types, two main groups. First group, we call it renewable. What do you mean by renewable energy? It means renewable source of energy. It means a source of energy which cannot use up. What's that mean? It means when you will use this source of energy, it will not end up, it will not finish. It means you can keep always using it. Example of renewable energy, wind power. Okay, wind power, as you can see here, this windmill, when a wind it hit these blades, it will start rotating, and here inside it there is a turbine. This turbine, when it will rotate, it will generate electricity. So here what happened, the wind will never finish up, it will never finish. So as much as you will use it, the wind, it will not finish. So this is an example of renewable energy. Another example, water power. Water power, what do you mean by water power? One of the ways that they used to generate electricity, it's using dam. Okay, so this dam, it's stored, there is water in front of it. When this water it flow, it moves through a turbines. These turbines, when it will rotate by the help of by the force of water. So here what will happen, the turbines will generate electricity. So here what happened, also source of water, okay, or the force that comes from water, it will not finish up. So this kind also of energy, we call it renewable energy. Solar energy. Solar energy, as you know, it means, so what do you mean by solar energy? The energy that comes from sunlight, the light energy. So the light energy, it will never finish up. So also now solar energy, it's another example of renewable energy. Biofuels. Biofuels, what do you mean by biofuels? It means a fuel that comes from living things. An example, wood. So wood, it's an example of biofuel. Okay, but maybe someone will say, but you mean wood that you mean wood that it comes from trees. If we will keep cutting trees and using it as a source of energy, the trees will finish. The answer here it's no. Okay, because a lot of trees are just growing by themselves. Okay, so wood, it's an example of biofuel which is used as a source of energy, and it belongs to the renewable energy. Questions. Question number 1. List the 4 ways of generating electricity mentioned above. Okay. Here, okay, wind power. Wind power, we can use it to generate electricity. Water power, also we can use it for generating electricity. Okay, here it's a river, dam, and waves and tidal. Okay, also they can be used to generate electricity, and also the solar energy. Then the second example, non-renewable energy resources. Non-renewable energy resources, it means a source of energy that once you will use it, then you cannot reuse it again. Example, fossil fuel. Fossil fuel, all the examples of fossil fuels, you can just use it one time. Example, let's say coal. Coal, when you will burn it, you will get energy from it. But after burning it, you cannot use it anymore as a source of energy. Okay, so these examples, we call them non-renewable energy resources. Okay, why we call them non-renewable? Because this is because once they have been burned, they are gone forever. Question number 3. Explain why wind energy used to turn a wind turbine is a renewable energy resource. Wind energy, we said you can use it more than time, okay? Or in another words, you can say as much as we will use it, it will not finish. So that's why it's an example of renewable energy resource. Nuclear energy, nuclear power. Nuclear power, it means getting energy from atoms, from atoms, or by getting the energy out from the nucleus of an atoms. Okay, we can get nuclear power. Okay, we called it nuclear energy. So nuclear energy, it's the energy that it comes from atoms, from the nucleus of an atom. 11.4, conduction of heat. Conduction of heat, what do you mean by heat? Conduction of heat, it's the transfer of heat through objects. or transfer of energy, of heat energy from one place to another. If we will take this an example, this as an example, okay, cup of tea and spoon, a metal spoon. Okay, if you will put this spoon in water, in this in this tea, okay, cup of tea, you will see after a while you the spoon will be hot. So what happened? Because the spoon it's attached to the hot tea, after a while the energy or the heat it conduct, it transferred from tea to the spoon, and then it goes through the along the spoon. Here we have another example. Okay, metal that it's made up, a rod that is made up of metal. Okay, and here as you can see we have pins are sticked with this this rod of metal. Okay, here we have source of heat. Now, as you can see, if we will do this experiment, we will see these pins will start falling one after another. Okay, explanation for this is what? We gave heat here at this point, but what happened? This heat, it moved or it transferred along this metal. Okay, once it reaches here, so this pin will fall. Then when it reaches here, this pin will fall, and so on. So this is what do you mean? This we call it thermal conduction. Okay. So thermal conduction, definition for it, it's what? Transfer of heat energy through objects. Okay. So here there should be contact. There should be two objects that they are in a contact. Here we took this example, tea and spoon. Tea and spoon, they are in a direct contact. Conductors and insulators. Conductors and insulators, as we explained before, when we talked about conductors and insulators in when we were talking about electricity, the same thing it's here. Okay, some materials are good conductors for heat, others are bad conductors, or we call them insulator. For example, let's say if you have a pan, as you know, it's made up of two parts. It consists of two parts. Okay, the pan and the hand of the pan. The pan, it's made up of what? It's made up of, usually it's made up of a type of metal. Okay, but the hand of it, it's made up of usually from plastic. Now the difference between metal and plastic, it's what? A metal, it's a good conductor for heat. Okay, while the plastic, it's a bad conductor for heat, or we call it insulator. Okay, here this drawing, it shows how the energy or how the thermal energy it conduct, it transfer. As you can see here, hot end, cold end. Here at the hot end, the particles, they have a lot of energy. Because they have a high energy, so they are vibrating faster. Okay, when they will vibrate, it will, for example, this particle will touch this particle. Now some of the energy of heat energy, it transferred to this particle. When this one it touched the next one, also the heat energy will transfer at the end until it will reach the last part of the this object. Okay, so this is what they mean by thermal conduction. 11.5, convection. Convection, also here it's another way by which energy the energy will transfer. Okay, so here we are talking about how energy it transfer. Okay, the energy it transfer through different ways. The first one, it was conduction. Okay, how you will know it's conduction? Here, the main word or the key answer for it, it's what? Two objects, they are in a contact. Okay, through materials, you will hear these words, through materials, two objects are in contact. Okay, then convection. Convection, here what will happen? The energy or the heat, it will transfer as what? As circles. Okay, it moves as circles. It will move from firstly here, let's say here it's a surface and here it's hot, so the air particles that they are here will gain energy, so will raise up. And what will happen? The cold particles will replace it. So here what is happening, the energy or the heat energy, it's transferring in circles. Okay, these circles, we call them what? We called it convection current. So warm air raising, okay, we call it convection current. Okay, the warm air will raise, the cold one will sink. Convection at home. Example of convection at home. Okay, uh, some of the houses, they have this heater, but let's take an example of the let's take this example. Okay, convection current transfers energy from heater to the rest of the room. So what is happening here? This heater will give hot air. This hot air, it has low density, so it's light. Because it's light, so it goes up. When it goes up, what will happen? The cold air, it's heavier. Because it's heavier, it will sink or will goes down. And what will happen? This process will continue until, for example, the whole room will be hot. How convection works. The examples that we took, I talked about example that it was about air. Okay, so convection can happen in gas or liquid. Focus here on these two words. Convection, it will happen in what? Either in gas or liquid, not in solid. Okay, but what is the reason behind this? Okay, it's what? Gas and liquids are able to flow. So any substance that can flow, the convection, it could happen in it. Now, if you will come to the questions, question number 2, it says, explain why convection cannot transfer energy through a solid. What you will say here, because the particles in solid are tightly connected together, okay, or tightly attached to each other. Because they are attached to each other, so the particles here, it cannot flow. Okay, which particles it can flow? Only gas and liquid particles can flow. Radiation. Radiation, the third example or the third way in which heat energy transfer. Okay, now radiation, once you will hear the word radiation, you will have some words like vacuum, space. Okay, so the energy that it transferred through empty space or through vacuum, through space. Okay, this kind of energy transferring, we call it radiation. Example, let's take this example: sun, earth. Sun, it will send energy to the earth. Okay, as you know, between sun and earth, in this distance, it's what? It's space. It's empty space. Okay, there is no matter in it, there is no air, there is no particles of air. So if there is no particles here, how this energy it's transferring? It's transferring by radiation. Okay, or it comes, the energy, it comes from sun to the earth as ray. Okay, example of ray, uh, it's like infrared radiation. Okay, good and bad radiators. Here we will take some example of materials that are good and bad radiators. For example, in summer, okay, in summer, they say don't wear dark clothes. Why? The reason behind this is what? If you will wear dark clothes, so this clothes will absorb too much energy, too much heat energy. So when it will absorb too much heat energy, so also it will emit, or it will gives out some of this energy. So this kind of materials, we call them good radiators. So the materials that are good absorbers, they are also good radiators. What does that mean? If it has the ability to absorb the heat energy, so it can gives it out. Here, matte black surfaces are good radiating heat energy. Okay, the black one or the dark one, they are good radiators. Okay, that's why the inside of an oven is often painted black. Okay, any object that the surface of it, the color of surface of it, it's black or it's dark, so it has the ability to absorb more heat energy. Because it has the ability to absorb more heat energy, so this we call it a good radiator. 11.7, evaporation. Evaporation, what do you mean by evaporation? It's turning the liquid into gas. Okay, water, if you will put water in a cup and you will leave this cup outside, you will see after a specific time, after a period of time, all the water will disappear. But what happened here, all the water it evapor. Now all the liquid water, it turns to what? It turns into gas. So this is what they mean by evaporation. Okay, evaporation cools you down. Let's say it's summer, the weather is hot, and you are exercising, you are playing, you are doing any kind of activity. When you will do any kind of activity, you will feel it's hot. Then how your body can regulate your body temperature, or how can your body lose this extra heat? So your body will start sweating. When your body will start sweating, this water that it comes out from your body, it's what? It's taking some of the heat energy from your body. It's taking it from inside of your body to outside to your body. So in this case, what is happening, it's the water is evaporating. Okay, the water it's evaporating. When it will evaporate, what will happen to your body? You will feel you will cool down. Okay, so evaporation, it helps our body to cool down. Okay, here it's explanation for evaporation, or how you will lose energy when your body will sweat. These particles, look at the particles, we have red one and a blue one. This the particles, let's assume that the red one, it's what? Heat. Okay, so heat, what is happening? It will start moving. Here it's inside your body, okay, and here it's outside your body. So when this heat particles, it will reach the surface, it escape from your body. When it will escape, now what happened? Your body will cool down. Your task is solving the questions, the end of unit questions. So, dear students, that was everything for the science book for grade 9. I hope everything was clear. Please, when you will finish watching this video, write a comment, write your name, so I make sure that everyone he received the video, he watched the video, and everything is clear. Again, if you have any questions, any concerns about any part of the book, please don't hesitate to text me or to write a comment in the video on YouTube. Have a good day and thank you.